Okay, now you can start, sir.
Okay, sir. Fine, sir. Okay, so hi, Anjali ma'am. I think someone is also joined, maybe Varsha.
Yes, 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 sir, she's Varsha.
Okay, fine. Okay, so today we'll see certain topics like hypothesis testing. So where we are going to see what is Z test, what is T test, and ANOVA related aspects. And since we know that hypothesis is just an assumption. Okay, so a hypothesis means either assumption or a claim, which should be either accepted or rejected. Okay, and usually as researchers we try to either prove some claim or we disprove some claim. So I believe that you have got some basic idea of hypothesis. So I'm straight away going to the topic. Like there are two types. Like one is null hypothesis, second one is alternate hypothesis. And we'll be seeing that type 1, type 2 errors also. But in this, we are not going to see in today's class. And coming to the null hypothesis, it usually believes the status quo. Okay, so there is no effect on any particular thing, even if it is any experiment or any particular new medicine or any product. So if it is developed, we feel that there is no effect on the observations because of this particular new medicine or new effect. An alternate hypothesis is there which tries to counter this one. So this is quite opposite, and this tells that there is an effect. Okay, if it is a medicine, they tell that it reduces certain problem, or if it is a weight loss treatment, there are certain companies which claim that if we use this medicine, your problem may come down, or if you use this particular product, your weight will come down. So to prove that one, so they need to prove this alternate hypothesis. So, and basically there are two types of hypothesis, like tail tests. One is two tail test and the second one is a one tail test. In one tail test we'll have left tail and as well as right tail test. And coming to this two tail test, usually the hypothesis, null hypothesis will have equal to sign. If there is an equal to sign, then definitely it's going to be a two tail test, where this is what the curve for that, and you see HA will be more probable. So this is what some kind of alternative hypothesis zone, and this is what alternative hypothesis zone. And this complete between area is related to null hypothesis. And if our calculated value falls in this zone, we tell that null hypothesis is accepted and there is no effect of that particular phenomena. And if our calculated value falls in this red zone, either right side or left side, then we reject null hypothesis, so that we obviously accept that alternate hypothesis. I hope I'm making sense, right? You are able to understand, right?
Yes, sir.
Yeah, fine. And so in two-tail test, we'll have these two things. Like we will assume that the population mean will be equal to certain value, maybe 80, 90, 100 according to the problem. Okay, mean value is 80, something like that. And alternate hypothesis tells that population mean is not equal to that 80. Maybe it might be less than 80 or greater than 80. Okay, suppose if you are trying to prepare certain screws of 80 millimeter. Okay, so in quality checking, we have to get exactly 80. And if you take any sample, we'll try to check whether the company is following that quality measure or not. We'll select a particular sample and we try to test that hypothesis. Okay, and obviously that operations department feel that status quo, like every screw that they are making is equal to 80 millimeter. And if there is any deviation, obviously we'll go this one, and that shows that there is some deviation in that, and the process has to be redefined or changed. So this is what the hypothesis with two tail. And coming to the one tail test, so as I told, one tail test is left tail or right tail. So here, if you see, null hypothesis zone is this one. So where the status quo will be accepted here. Okay, so even here we tell that the thing which we are producing is greater than or equal to 80 millimeters, so 80 centimeters something. Okay. And if it is coming less, obviously customers will be having certain problem. Okay, the quality will not be up to that thing. So that is what this one, that project has to be rejected. Okay, so this is what the left tail. Okay, and for null hypothesis, definitely we'll have greater than or equal to symbol. For alternative hypothesis, we'll be having less than symbol. Okay, if you are rejecting this null hypothesis means, then definitely the value is less than, and it is the alternate for that one. So that should be taken care. The process should be taken care under such circumstances. Is that clear about left tail, one tail test? Fine, or any doubt in this? Because this is the basic theory which we have to understand. So then only we'll be able to perform that Z test or T test or any other test. Is that fine, people?
Yes, sir. So, but
Fine.
in this one
Yeah.
tail test,
Yeah.
the first option, H naught, which we have written, mu is greater than or equal to value, right?
Yeah. Yeah.
This is not null, right? This will not be called null, right?
So that will be called as null only, because the null hypothesis will assume that the particular item which we are producing, the mean of that item is greater than or equal to 80 millimeters.
Okay, so null is not only equal to, but
That's what. That's what. So in the case of null hypothesis for a one-tail test, so this is what, if only less than, then we should be considering it as alternative hypothesis. Opposite to that is not simply greater than. Either that should be either greater than or equal to. Okay. Because there are certain things, even certain value, if it is greater than or particular, like suppose if you take newborn baby, usually that should be 3 kgs. So this is what usually people feel. If it is 3.5 kgs, there is no problem, right? If it is 3.8 kgs also, there is no problem. If it is less than 3 kgs, then there is a problem. For that, we need a treatment. Okay, so in that say cases, we'll call it as greater than or equal to.
okay.
Okay. Similarly, if it is a one-tail test, right-tail test, so where the rejection region is this one, and the less than thing is that one. Okay, so this is what null hypothesis value, like it is less than or equal to. There are certain things like blood pressure. It should be less than 150 something. As a higher note, it should be less than or equal to 150. So till that time, it is okay. We can approve that product, or we can feel that the person is quite healthy. If it is beyond 160 or 170, then we feel it as there is something which has to be done for that person, or the product also should be taken care at that time. So this is what right tail test, where the problem comes with the right tail. Is that fine? Left tail, right tail, two tails.
Yes, sir.
Okay. Now we have to reject null hypothesis. That Z statistic is what something which will be calculating, and Z critical is what some kind of table value. So when I have already shared this document just now with Farah, and she'll be sharing the total document and critical values like T test, T values, Z values, F values. So that is what considered to be the table values. So this is table value and this is the calculated value. And when calculated value is less than this critical value, we have to reject null hypothesis. Or if you take the positive side, when the Z calculated value is more than the table value, we have to reject that null hypothesis. Once we see the problem, we'll be able to understand how we are going to reject and accept the null hypothesis, right?
Sir,
Yeah.
sir, in the previous slide, sir, yes, this one, sir. Right tail and left tail is just opposite of each other, sir. How will we come to know that in this research we are considering right tail, and in this research we are considering left tail?
Nice. So very good question. I have got some problems for left tail, right tail, two tail. So there you'll get clear idea. Fine?
Okay, but means we can make out by seeing the
definitely. So by seeing that, we can tell that if any particular value is going to be less than or coming down, there it creates a problem. Under such circumstances, we call it as a left tail thing. Okay, so in this case, if there is something more than a particular value, which will not be a problem. Series of concern. If there is coming less than value continuously, it is a series of concern, serious concern. So we have to take care of that one. So there are certain values which have to take care like that. And in the problem itself, once you read the problem, you'll be able to understand what exactly is a problematic thing. Less than is a problem or greater than is a problem. So such kind of things will be there in the next slide. Right?
Yes, and one more thing, sir. How do we decide whether we should consider a two-tail thing or a one-tail thing?
Yes, that depends upon the question, like whether the person, even for that, I have got a same problem I have done for two-tailed as well as one-tailed. So you'll be able to understand in the coming slides. Is that
Okay.
fine?
Yes,
Okay.
sir.
Okay. So, and the testing, there are two things. Like majority of people, even I get confused, like which test to be used, either Z test or T test. So Z test, when we have to use Z test, and when we have to use T test. So statisticians will have lot of assumptions for them. And usually if the sample size is more than 30, a higher sample will always attract, or it should be given solved with the help of Z test. If sample size is less than 30, then we'll be using T test. Okay, so this is what the first thing that we have to remember, right? And this data will follow a normal distribution. So if any data is following normal distribution, then automatically we will be preferring Z-test. And there is something called as a data follows a student T distribution. So for such case, we'll use T-test. And we'll try to differentiate what is a student T, distribution and a normal distribution in the next slide. Okay. And the one sample Z test is given by some formula. So that is X bar minus mu divided by standard deviation divided by N. And the T test will be used. Only difference between these two is, if you see, this is standard population standard deviation divided by square root of N. This is sample standard deviation divided by square root of N. Only that will be different. Apart from that, the procedure, each and everything is same, right? If sample size is more than 30, we use Z-test. If sample size is less than 30, we use T-test. And Z-test will follow a normal distribution and T-test will follow a student T distribution. Only slight change in that curve. And for one sample Z-test, we use X bar minus mu divided by standard deviation, population standard deviation divided by square root of the sample size. And coming to the T-test statistic, we'll use X bar, so sample mean minus population mean divided by standard deviation of sample divided by square root of N. And how do you identify like which should be used? If it is sample size, based on sample size, you can make out it is 30 or more than, less than 30 or more than 30. And when in the question, when population standard deviation is given or known, then we'll be using Z-test, where you can see this is the differentiating factor. Okay, so I have used standard deviation sigma here. Okay, because I know my population standard deviation, which is being given in the question. Okay, when population standard deviation is not given or unknown, when population standard deviation is not given, only sample standard deviation has been given, then we'll take this T-test. Okay, so for that, you see, the only differentiating factor is I have used S as standard deviation. Okay, for population and sample, I hope you know the difference between population and sample.
Yes.
So we'll simply mention mu here, we'll mention X bar here. Okay, and for variance, we'll mention sigma square. We'll mention we'll mention S square here. For standard deviation, we'll mention sigma here, we'll mention S here. So these are simple things which you have to remember. And by seeing that, you can make out like what is this. And this hypothesis testing will come in something called as inferential statistics. Okay, so inferential statistics. Can anyone just quickly tell what do you mean by inferential statistics?
So where we use statistical analysis to infer it to the general population also. Like we are taking a sample and using the statistical analysis and inferring the results for the whole population.
Very nice. So this is what the total population, and I've got many people are here. Okay, now you can see that there are 5 elections are happening in different 5 states, and they're telling that BJP will win this much, Congress will win this much, Mizoram, something like that. So they will not ask each and every person in the population. They might take some people from here, some people from here, some people from here, or different, and they take it as sample study, and they'll study what is the pulse of this sample, what is the pulse of this sample, and what is the pulse of this sample, and what is the pulse of this sample, and they attribute that results to the total population. So this is what inferential statistics. By studying these populations, they try to infer or give a result for the total population. Okay, most of the people are feeling like that in this sample, so this might be applicable for the total population. Okay, so that is what inferential statistics. For that, we'll use the z-test and t-test. Okay, the primary differentiating factors are number of sample. Apart from that, if we were given the total population variance or standard deviation, so then we prefer z-test. If the population standard deviation is not given, only sample standard deviation is being given, so then will you prefer t-test. Okay, is that fine? Is that fine? Can I move ahead? Or any doubts? Because till now I got answers, but if silence means there is a doubt. Is there any doubt, or can I move ahead?
No, sir, it is clear.
Fine. So coming to the parametric test and non-parametric tests. Okay, so this bunch is called as parametric tests, and we'll see when it will be used, and in the next class we'll see this one, non-parametric test. The main difference is this thing will assume a normal distribution. Okay, and in this case we will not assume a normal distribution. We'll use like this, or we'll use something like this. Okay, this is what some kind of skewness. Okay, if the data is not normal, so then we'll use non-parametric test. If the data is considered to be normal, okay, so some kind of normality assumption, then we'll use parametric test, which consists of simple t-test. It is if we are using only one sample data, so then we will use a simple t-test. If we use in the given data, if you are talking about 2 dependent samples, if one is dependent on other, like suppose if you are taking some people who have got who have undergone some weight reduction treatment. Okay, so before weight, after weight. So as you are trying to find out the weight of these people before and after, and this is the same sample before the treatment, this is the same sample after the treatment. Is there any weight reduction happened or not? For that, we use paired sample t-test. Okay, because you are trying to find out what is the difference in this person 1, what is the difference in person 2 in terms of weight, what is the difference in weight 3 of this person before and after the treatment. For that, we use something called as paired sample t-test. Okay. And if you are talking about a non-parametric test, we use something called as Wilcoxon test. Okay, so this is quite similar to this one, but the data distribution should be following a not normal distribution, some kind of skewed distribution. And if you are talking about 2 independent samples, okay, so 2 independent samples, then we use something called as unpaired sample test. Okay, suppose these are the people who are living in Jharkhand area, and these are the 3 people who are living in some kind of Mizoram area. Okay, if you're trying to find out what is the opinion of these people on a newly released movie, okay, and we try to find out some three people opinion on a newly released movie, as these three are different and these three are different. So under such circumstances, we go with something called as independent sample, so which is called as unpaired sample t-test. Is that clear? The difference between paid sample and unpaid sample. If you're trying to compare same people, because in this class there are 5 students. Okay, if I try to check the knowledge level of the statistical knowledge level of people before this sessions, like this total course, and after this course, then that is called as a paired sample t-test. Unlike that, if I take 5 students from here and if I take 5 students from some other institution or some other thing, so then that is called as unpaired sample t-test, because I'm talking about 2 different samples. Okay, is that fine?
Yes, sir.
Now a student may get a doubt like, okay, so if as you're trying to compare 2 samples, either maybe dependent or independent, fine. Suppose if I want to compare 3 groups or 4 groups, so then what is the position? So then what is the tool available? So for that we use something called as ANOVA, analysis of variance, which tells about mean differences of more than 2 or 3 groups. Okay, 4 groups, 5 groups, 6 groups, something like that. Okay, if you want to find out like what is the pulse, like now if you see 5 states elections are happening, if you want to check what is the pulse of different samples in 5 states with respect to BJP government or some Congress government, so then you go prefer these sort of things. Okay, this is what just a contemporary example which I just wanted to quote. Apart from that, if you have 5 different sales person who are working in your company, if you want to check is there any difference among the performance of these 5 or the same, for that purpose you cannot use t-test or z-test. Definitely you have to go for ANOVA test, because you're dealing with more than 2 groups. Okay, and if you are trying to find out the correlation between 2 variables, if the data is distributed normally, you can use Pearson correlation. If the data is not normal, we have to use Spearman correlation. Okay, if you are using any R or Python or almost all these softwares or some kind of packages, differentiate these two. Okay, slightly differentiation, but there is a differentiation. For that, you have to check the normality. Okay, so how can you check normality? Because I believe we have seen that class also. How can you check normality of the data? When do you tell data is normal or not normal? Any idea?
Sir, if mean, mode, and median, all the 3 is at the same point, then it is normal distribution.
Absolutely. If these 3 are same, then you call it as normal. If it is not, if there is a deviation, obviously it is called a skewed data. For that, you have to just go for non-parametric test. And you might have seen something called chi-square analysis. So the chi-square table itself will be like this. Okay, that shows it is not normal. So for that only, that is called as non-parametric test. Okay, and I'm assuming that you are quite okay with this and moving to the problem. Is that fine, or do you want me to spend some more time in the previous slides? Is that fine?
Yes, sir.
Fine. Now a student asked like, how do you differentiate a two-tailed test, or how do you differentiate left test, right test? Okay. Now you can only answer that by saying that there is a shampoo company which manufactures shampoo sachets of 80 ml. Okay, 80 ml, and the standard deviation as 2.5 ml. So this is what they feel that their total population is following this one. Okay, so as they have given a data like this, suppose assume that if any shampoo sachet, if it is greater than 80 ml, what is the problem, what is the advantage, and who will be advantage or who will be a disadvantage?
So the manufacturer will be at loss because they are giving more, like they are losing more but getting paid for 80 ml only, and the consumer will gain with this.
Okay, do you want to, since we are manufacturers, since we are teachers or some kind of operators, is it good to is it good to continue greater than 80 ml, or we have to curtail that?
Yeah, we need to curtail that.
We need to cut down that. Fine. So, okay. That means if there is a deviation here, like greater than 80 ml or 81, 83 ml, we have to cut down that. Okay. So this should be rejected. Assume that we are producing something which is coming to be less than 80 ml. Is there any advantage or disadvantage? If so, who is advantage or who is at disadvantage? Our production is coming to be less than 80 ml, 79 ml, 78 ml, 76 ml. Is there any advantage for us, or who will be at advantage?
So there will be because there will not be, because we are as manufacturers are saying that it is 80 ml.
Mhm.
Any customer could claim and then could say that they are being cheated. But if it goes unnoticed, then it is okay for the manufacturers maybe.
Definitely. But there
Customers
is
will
something
get
called as
lost.
business ethics that we have to follow, that usually
For the
companies have to
product.
follow.
Yeah.
And obviously, one day or the other day, customer will come to know that, and
Yes.
definitely
So it
he'll
should be
shift to the
80
competitor. Okay, whether this has to be cut down or not.
curtailed, sir. It should be 80 ml. If it is written 80 ml, it should be.
Definitely. So, like, what is danger? If it is going beyond certain things, 80 up to certain extent, it is okay. Maybe 81, it's not a problem for the company. Not a serious issue. 79, it's not a serious issue. But if it goes beyond that, there is a problem, right? So this should be avoided. And this also should be avoided, because we have seen something called as, this is going to be producer's loss. This is going to be consumer's loss. Okay, so these two should be avoided. Now tell me whether this has to be taken as a one-tail test or a two-tail test.
A two-tail test.
Definitely. I think someone asked, like, how do you identify one-tail, two-tail? Is that person quite okay, or any doubts for that person? Who asked that question? Doubt?
Varsha ma'am.
Varsha ma'am. Ma'am, Varsha ma'am, are you
Yes,
okay
sir.
with this?
Okay, sir.
Okay, so the simple thing is, like, whenever we go, we get something, and here they have mentioned that 80 ml sachets, and they're quite okay with, there is some kind of tolerance limit, like plus or minus 2.5 is not a problem for them. So this is what for a 80 ml sachet. And the operations manager wanted to check whether are they manufacturing the sachets of 80 ml or any deviation is there. If there is a deviation, if it is increasing beyond a certain limit, 82.5, it is considered as a producer loss. And if it is less than 77.5, it is going to be the consumer's loss. Both are not correct, or both are not good for the institution or the company for a long run. Okay, because as the companies are dependent on customers, definitely we have to give fair value to the customer. So both should be taken care. Okay, you should not go beyond plus value. At the same time, you should not go beyond minus value up to a certain extent. And so he just wanted to identify how they are doing. So he has identified a sample of 40 sachets. He got 40 sachets, and he has taken mean of that 40 sachets come to be 78 ml. Okay, there is 78 ml of that 40 sachets. Okay, maybe 81 will be there, 76 will be there, 75 will be there, 82 will be there. But how many he has collected? He has collected 40, and he found that mean value of that is to be 78 ml. And now we have to test the hypothesis at 0.05 significance level. Okay, that means 95% confidence level. The confidence level is 95%. 5% is going to be the significance level. Okay, so that's why I have mentioned 0.05. I hope you know the difference between significance level and confidence level, right?
Yes, sir.
There might be chances like 5% are there. So that is what alpha, the significance value, the type 1 error, we call it as alpha, 0.05. And the population mean, what we have assumed is 80 ml. That is what the population mean. So that is what given in this case. And what is the standard deviation? The standard deviation is whether the standard deviation is for a population or sample.
Population.
Exactly, because when this is what the initial data which has been given, and if they have not nothing mentioned means it is considered to be the population only. And coming to the sample, they have mentioned when there is a sample of 40 sachets, mean is found to be 78 ml. And they did not talk about your sample standard deviation. Okay, so here now we have to check which test should be used. First checkup we have done, and we identified this to be two-tailed test, because you have to check whether it should be less than 80 or less than or not less than. Okay, this is not okay. There is some error, so don't read this. So the shampoos sachets should not be less than 80. At the same time, it should not be greater than 80. As customer is claiming mean rate is not 80 ml, there is a deviation. Maybe he's claiming that it is less than or greater than. So we have to curtail both the sides. So it has become two-tailed test. So that is the first confirmation that we got. And second confirmation is, in the last slide, I have mentioned in this slide, when population standard deviation is given, which one we have to use, Z-test or T-test? T-test. Z-test. Okay, so that is what we have got. So that is what our thing. And as I mentioned in this slide, like for population, we have to use mu. For sample, we have to use X bar. For population, we have to use standard deviation sigma. For sample, we have to use standard deviation S. Okay, so if you just go with that formula, so the and for two-tailed test, we have to follow this particular pattern. Is equal to means null hypothesis, because the operation manager is still feeling that we are producing some manufacturing certain things which are equal to 80. There is a question by researcher or a customer or some person. He is claiming that no, you are not producing 80. There is a deviation. Now we have to prove him either this is correct or this is correct. For that we are doing. Is that fine? Understood the question or any doubts?
Understood.
Fine. And the sample mean, this is what we initially assume as 80, and the population mean. And sample mean is we have calculated with the 40 sample, and it is found to be 78. Okay. And sample size is 40, which is clearly given in the problem. Okay, the other confirmation here is as whether the sample size is greater than 30 or less than 30.
Greater than 30. 40
so then we have to use a Z-test. Okay, and coming to the Z-test, so this is the formula to calculate the Z value. Okay, X bar minus mu divided by standard error. Okay, and some of the people feel like in some books, you will see this as standard deviation. The simple difference is when you have been given a particular sample, then we have to just go for standard error only. Okay, because the standard error may differentiate the total thing. Okay, the total Z value will be differentiated because of this standard error. If you are making an error for 10 observations, that is something. If you are making that errors for 1,000 observations, might not be a big problem. So that sample should be given weightage when you're treating these things, right? And I'm simply applying this thing. 78 is my sample mean, X bar. My population mean is 80. So that is 78 minus 80 divided by standard deviation is here, as I've just mentioned, this is the population standard deviation, right? So I have used straight away that 2.5 divided by total sample of 40, square root of 40. Is that clear? Just application of formula. I did not do anything. Is that okay?
Yes, sir.
With that, I got the values minus 5.506. And as you're trying to test this particular value at 0.05 significance level, this is the calculated value. So this is called a Z statistic. And if you see the table value is going to be like this. Okay, so 95% of the data should be lying here, which is considered to be the good sample, like for 80. And the deviated sachets will go, if it is more than that one, it will go to the right side. If this is less than that one, it goes to the left side. And according to the table, it should be minus 1.96 if it is coming less than, and if it is going plus 1 point, if it is going beyond 80 or something, it should be 1.96. Okay, according to the table. I will share the table also along with that so that you can see. Okay. And now, as it is coming to be minus 5.506, the sample, what should we do? Whether we should accept null hypothesis or we fail to accept null hypothesis?
Accept null hypothesis.
Should we be accepting null hypothesis? Because your mean should be 0 and we have got a value which is lying at minus 5.506. So
Which
it is very far from the exception region and it should be rejected. Okay. And the particular...
I got confused.
Yeah, no problem, no problem.
Yeah,
Because
it is
one of...
that only. But
one of the famous personalities from operations research tells that if you start with confusion, you will end with confirmation. Okay.
So our because we were as the null hypothesis is mu is equal to 80, right? So
yes.
Yeah.
We are trying to test the total population mu with the help of X bar. Okay, so and we have calculated the value, Z calculated value is minus 5.506. And if you see the value with the table, it should be rejected. Okay, that means the mean weight of shampoo is not equal to 80 ml. And it gives an indication that most of the times it is going back. It is coming to be less than 80. Suppose
and going beyond the means
beyond the limit, beyond the threshold limit. Okay, and if assume that if it has become like plus 2.6, that shows that producers loss is more. In this case, customers are losing more because we are telling that 80 ml, but maximum of the people are not getting that one. Okay, so this is what the problem, right? The same problem can be done in one way also. Like claim should be like, in that case, what you should be doing is, if you are asked to find out in a one-way test, so H naught should be equal to, the company people will tell that we are giving something which is more than 80 or at least equal to 80. But customer is challenging us, stating that no, you are giving less than 80. In that case, it goes this one. So this is how, if you want to do this same problem in one-way test, okay, one-way t-test. I think someone has asked, so is that fine? Someone asked like the doubt, like the same problem, if you want to make it as a one-way test, you can just define your hypothesis like that. Okay. Under such circumstances, your rejection area will come only this side. Okay. So this side, it is going to be left tail if you want to check that the same problem as one-tailed test. Is that clear? I think someone asked out. Fine.
Yes, sir.
Right. Okay. If it is clear, I am going to the next one. So here, this is the first problem which we have seen as a two-tail. So a teacher claims that, maybe I can also claim that my students are good, and the mean score of the students in her class is greater than 82. Okay, one teacher has told that my students are very bright and the average score is definitely more than 82. And the standard deviation is 20. she has mentioned that standard deviation is 20. If the sample size of 81 students have been taken with a mean score of 90, check if there any evidence to support the claim at a 0.05 significance level. Okay, now you should be telling what are the values. Forget about the values which I have shown here. What have been given and what is the sample size here?
81 students.
So which test I should be using? T-test or Z-test?
Z-test if you are looking.
Because 81 students, Z-test, right?
More
And
than, yes.
yeah, and teacher is claiming my students are getting more than some value. Okay, my students are getting more than some value because some value, the mean value is 82, and she is telling that my students are getting more than a particular value. And which test we should be using? Either less than, less or more. Is it a right tail or left tail?
Great. Done.
Is it? It is a
Right.
right tail, because her claim is, so
Completed
this, yeah, this is what something. Okay, so usually the status quo will tell that no change, everyone is getting 82 on an average. But that person, that teacher is challenging that no, I can prove that my students are falling in this zone. We have to check whether that is right or wrong. Okay, and so that is what the null hypothesis and alternative hypothesis. Coming to the null hypothesis, we have just mentioned that average score is, the total population average score is less than or equal to 82. Okay, ideally it should be equal to 82, but as the person is challenging, so we consider it as less than or equal to 82. And the challenging person is telling that no, I can prove that my students are more than 82. Okay, so now the significance level is same, and I hope you understood the thing. Okay, so Z-test we have to use, right tail test something. So as we are talking about either greater than or less than, then we have to differentiate whether what is that they're trying to do. Is it one tail or two tail? Okay, and the same formula, everything same application. Here we have identified as sample. Fortunately, that sample has become 90. The sample students who got selected got 90. Obviously, 90 minus 82 is going to be a positive number, first thing, divided by standard deviation. Yeah, the second observation, what is the standard deviation? Is it sample standard deviation or population standard deviation?
Population,
because that has been given in the first thing. And also, whenever they have selected a sample, they did not tell anything about the standard deviation. Before selection of the sample itself, they have mentioned standard deviation is 20. That means the school has got set some kind of limits, like plus or minus 20 is my standard deviation. So that is going to be a population standard deviation. Okay, and Z value has become 3.6, right? So if you see that one, this becomes a right tail test. And according to the table value, if you see the table value, it is more than that. Okay, so definitely we can tell that this null hypothesis is rejected. That means, as null hypothesis stating that less than or equal to 82, this is not correct, boss. This is correct. Whatever the teacher is confident is absolutely fine, and we accept that one. That's why we have to tell that we fail to accept the null hypothesis or we reject the null hypothesis. Is that clear? Clear or any doubts?
Yes.
Fine. Okay. So next problem is someone now the other problem is a company manufactures batteries for automobiles and average life is expected to be 2 years. Okay, the company is feeling that the average life is 2 years with a standard deviation of 0.15 years. Okay, now what is some population mean? 2 years, which is straight away given in the problem. Okay, and standard
two
sorry?
Or
yeah, 2 or more. So,
equal to 2.
Yeah, so straight away we can simply feel that 2 years. Okay, average 2 years. It might become more than that also. That is what the confident they are about. And the standard deviation is 0.15. Okay, 2 plus or minus 0.15 is the overall expected value of that particular thing. And an engineer believes that the battery is not giving coming to be 2 years, and he wanted to check what is the problem, whether that is right or wrong. And he collects a sample of 100 batteries and found average life as 1.8 years. He has collected he has collected data of 100 samples, 100 batteries, and found that average life is 1.8. Okay. Now at 5% significance level, we have to test the claim. I have taken 5% in majority of the cases because most of the people will be 95% confident. Either you can go with 99% also or 90% also. So once I share the table values, you'll be just coming to know what exactly is 90%, 99%. And I believe almost all of you are quite aware of these things, right? And yeah, that's what. Question understood?
Yes.
Okay. And an engineer, what is the claim of that engineer? He wanted to show that the company is wrong. Okay. So then he is trying to target at less than 2. But company is feeling that greater than or equal to 2. Okay. Now I think you'll be able to understand like when to use two tail, when to use less than or equal to, when to use greater than or equal to something, right? Because most of the people will get confused until they practice to the maximum extent. Okay, so I'll be sharing certain problems also for your practice so that you can get a fair idea. Okay, if this is understood, I'll go to the next part. The same application like x bar minus mu divided by standard error, the standard deviation total population divided by square root of n. It is come to be minus 0.133. If we just go through that particular value, as it is a one tail test, minus 1.645 is the rejection region. Suppose if the calculated value is minus 1.8, we would have rejected that claim of engineer. But in this case, we cannot reject the null hypothesis because it is coming to be 0.133. So as mu value, normalized mu value is 0, and the value which we have calculated is falling here only. It is falling here. So it is falling in the 95% zone and not that 5% zone of rejection. So we fail to reject the null hypothesis. That means we are accepting that one. And obviously the claim made by engineer should be rejected. Is that clear? In the last two cases, we have rejected null hypothesis and we have accepted alternative. Okay, but in this case, we are not able to reject the null hypothesis, or we fail to reject the null hypothesis. Clear, people?
Yes, sir.
Fine. So this value is just a calculate the table value, which will be there in the table, which I'll be showing at the end of the session. So now, till now, we have seen something called as Z test, one tail, two tail, because we have seen more sample, more number of sample greater than that one. So if you see, I've mentioned what is this normal distribution. So standard normal distribution will be this green line, okay, which will be like that. And the T distribution is this particular red line. The T distribution is red line, which is almost equal to 30. That's why whenever the your sample is 30, some of the people use T distribution only. Okay, if it is beyond 30, then they'll go for normal distribution or Z table. Till the if the sample is 10, 20, 25, 26, 28, till 30, people use that one. And if it is a T distribution, which is for less than smaller thing, we use something called as this one. Okay. If you see this one, we should be remembering something like skewness. It's not skewness, peakedness. So what are the three types of kurtosis that we have seen so far? Mesochatic, platychatic,
And
leptochatic.
leptochatic.
Yes. So this is what some kind of peakiness. So depending upon that, we use a t-test. Like whatever we have seen in the last classes, I'm just using that to the next level. And usually this t-test works almost similar to z-test. Only difference is we will be using lesser number of sample, even for a smaller portion. Even if you take 6 sample, we can use t distribution or t-test, but cannot be used by that. But we cannot use that z-test. But majority of the people, like some of the people, even the statisticians also use these two synonymously, but that should not be, that is not correct, right? Okay. And t-test has been proposed by a person called as William Seeley Gossett. Because of some intellectual property rights thing, he in the institution which he was working, he was not interested to give the institution's name to that test. Okay, so when they have forced, like in history, some people have forced him to use the institution name. So he don't wanted to use that institution name, and he has named it as with his pen name, student t-test. So that is the reason why we come across either t-test or student t-test in some of the cases, right? Okay, so with that, I'm just going to a particular example, right? So is that fine? Or okay. So a company is trying to promote its product by claiming that the mean grams of protein in the packet is some 20 grams. So mean is 20 grams, and they just wanted to tell the standard deviation, the product which are selling is 20. It is almost similar to the sample sachet that we have seen, but the only difference is we have got something called as sample mean and sample standard deviation. Okay, so and the sample size is here 30. Earlier we have in the first example we have taken sample of 40. Second, that's why we have used z-test. In second example we have taken 100 sample. We have taken z-test. This example, the sample size is 30. So we are taking t-test. Clear? And we have to do similar kind of work. Only difference is going to be the sample standard deviation. So here, if you see here, the mean packet is 20, the mean value in that is 20 grams. The population mean is 20. And they just studied something which is the sample mean. Okay, so the sample is mean is not here. The sample mean is 21.254. And sample size is 30. So these are the details given in the problem. And sample standard deviation they have given as 2.407. Okay. Now we have to check whether the 20 ml, 20 gram protein is existing or not. Okay. And for that, as the same thing, either higher note is not correct for the company or lower note is also not correct for the company. That's why we go for a two-tail test. So as people are telling that 20 is the mean value. Because the population mean is 20 and sample mean is 21.254. The population standard deviation is 2.407. Now we have to just check what is happening here. Okay. As the number of, this is what the data given here. Okay. So they have given the data. Okay. So that's why they have given a data of these 30 samples. And you have to find out mean value. How can you find out mean value of this data? Because we have seen that also. In the question, they have not given any sample mean, but they have mentioned standard deviation as that one. So how will you find out the mean of this data, 30 observations?
Sum divided by 30, sum of the
total of all observations divided by total number of observations will give us this particular thing. Okay, so and once I'll share that Excel sheet with this where the calculation has been done. It is coming to be 21.254. Okay, and standard deviation they have mentioned is 2.407. And so this is the population mean. this is the sample mean, this is the standard deviation, this is what the total number of observations. If you use the same formula, the formula is quite same. X bar minus mu divided by only this is different most. Okay, so only this standard deviation is the samples one. Okay, if you use that, we got value as 2.85. And there is a T table exactly like Z table, which contains that at 0.05 at 5%, degree of freedom is 29 because we have to consider n minus 1. The number of observations is 30. So 30 minus 1 is going to be 29. So at that value, the T table value is going to be 2.045. As the calculated value is more than that one in terms of positive, what will we do? We reject the null hypothesis. That means average protein is not equal to 20 grams. Okay, because even if you get more protein, there is something called as proteinuria. I hope you might be knowing this value, right? This term, right? Proteinuria. That is a problem which is which is affecting some people, because you should not have more protein also. This is also not correct, and this is also not correct. Okay, so less protein is a problem. Similarly, more protein is also a problem. So to tell that this sort of product should be rejected. So that's why we have rejected that one, rejected this null hypothesis. Okay, it is not equal to 20. That means this should be rejected. Is that clear?
Yes, sir.
Okay, so next, two sample T test is one. So wherein this can be done for two tests. There is an automobile company. There is a company which wanted to test the mileage level of its vehicles in two different climatic zones. They want to check whether in both the climatic zones, whether they'll have same mileage or not. And in the first climatic zone, they have got 10 observations. In second climatic zone, they have got some 20 observations. Okay, so some 20 observations. If you try to check the mean, the variance, and the standard deviation, and the number of observations, all this we have already done in the earlier classes. So I'm just assuming that you are quite okay with this one. Now we have to find out, is there any difference between the mileages in two areas or not? For that, the formula is going to be this much. Okay, so T test x1 bar minus x2 bar divided by square root of s1 square divided by number of observations in the first observation plus variance s2 square divided by number of observations in the second set. Okay, if we just consider that one, we have calculated. So this is going to be x1 bar in the table, and this is going to be x2 bar. We have to just deduct this from this, divided by variance of the first set of observations is in the right side. Variance of second set of observations are here. N1 value is this one, N2 value is this one. Okay, if you consider these things, we'll get a value which is called as T is equal to minus 2.685. Okay. And if you see a two-tailed value, because as you are trying to find out the difference, is there any difference? No less difference should be there. Similarly, there should not be any more difference. So it becomes a two-tailed test. And at now we have just mentioned 28 here, because if you see N1 is 10 plus N2 is 20 minus 2. Because N1 minus 1 plus N2 minus 1, it's going to be 28. So we get the degree of freedom as 28. If you go with that value, it is going to be 2.048. And our calculated value is minus 2.685. Definitely, there is the first set of observations has got a less performance when compared to this one. That's why I got a negative value. In addition to that, it is beyond 2.01048. So that should be rejected. So that means mileages in two areas are not same. Clear? Is that fine? Guys, is that fine?
Yes, sir.
Any doubt? Okay. Yeah. Yep, please.
T critical is positive, sir. So how will you compare with this negative T score which you have got?
Yeah,
Both
for
will be there
T
for both
test.
on both the sides, right?
Yeah,
The
yeah,
value
yeah.
will there.
For
It could be plus minus.
plus or minus 2.048. Plus or minus 2.048 will be considered, and that too for a T table. Okay, I'll be sharing that table also, right? Okay, even in the last case, if you just see this one, okay, so here he got positive, but it will be considered for plus or minus. Okay. Okay, or any further doubt?
So next class I'll ask further down.
Okay, fine. So that's what, like, I think I've got. So this is 23. I've got 3 more slides, but it is what some kind of self-explanatory. So I have already shared this with Farah ma'am. So she'll be sharing that with you today, and the same thing. Like, so definitely we'll see this in the next class. But meanwhile, you can just go through that before you come to the next class. Okay. And in the last, I've mentioned T table values as well as Z table values also. Okay. Fine. So whatever the doubts, that definitely I'll take in the next class. Right? Sir, I'm done for today, sir. I was a bit fast to cover the maximum extent. That's what. Ma'am, Farah ma'am, is that fine?
Yes, sir. Yes, sir. We can end the session, sir.
Yeah. So today I'm ending the session, and I have shared that PPT with you. Thank you, ma'am.
Yes, sir. I will post it in the Google Classroom.
Yeah.
Thank you.
Okay. So thank you. Good night, sir. Good night, ma'am. Good night.
Good night.
Bye.
Good night, students. Bye.
Yeah.
Good night.
Ma'am, is Sar is in class or Sar is taking any other session?